Welcome to eMahiti Vivaranayalli. We're diving straight into a world where absolute precision is literally a matter of survival. Today, we're unpacking the master blueprint of structural integrity. We're talking about the raw engineering science, the heavy mathematical lifting, and the flawless site practices that keep our modern world standing tall. So buckle up, because we're about to pull back the curtain on the invisible forces all around us.
It's the ultimate nightmare, isn't it? Why do buildings actually collapse? Picture it like an IMAX documentary for a second. You've got these terrifying, jagged cracks creeping in ultra-slow motion through massive concrete columns. You've got the violent snapping of steel rebar under just unimaginable pressure. And then, finally, this devastating explosion of dust as tons of material crash to the earth. It is a violent reality, and it happens the moment the laws of physics are ignored.
It brings us to a chilling truth. ಒಂದು ಸಣ್ಣ ತಪ್ಪು ಇಡೀ ಕಟ್ಟಡವನ್ನು ನೆಲಸಮ ಮಾಡಬಹುದು. One small mistake can literally level the entire building. Just think about the gravity of that for a second. Out on a construction site, there are no second chances. You don't get a do-over when pouring a foundation. A single miscalculation, a tiny shortcut in materials, or even just a momentary lapse in supervision can trigger a fatal chain reaction.
Section 1, the Engineering Expert Introduction.
Now, the good news here is that these catastrophic failures, they are completely preventable. The utter chaos of a real construction site is tamed by rigorous, uncompromising science. But to bridge that massive gap between complex theory and physical reality, you absolutely need a professional at the helm. Enter engineer Abubakar Bavikati, a consulting civil engineer based right in Hunagand. With his serious academic credentials in public health and civil engineering, he's exactly the kind of authority structural safety demands. He's not just sitting in some fancy office flipping through blueprints, he is out there on the ground. We're talking measuring concrete mixtures, checking laser levels, inspecting steel detailing. It is this intense, hands-on supervision that guarantees the science actually makes it into the physical building.
Section 2, Real Site Execution Steps. Okay, let's dive right into this and look at the exact chronological process of professional site execution. How does a flat drawing become an indestructible 3D structure? Well, everything on site follows a very strict rhythm. Step 1, centering and shuttering, creates our perfect mold. Step 2 brings in the steel tying, locked in with precise laser leveling for absolutely flawless alignment. Step 3 is the critical concrete pouring phase, immediately followed by rigorous vibrating to force out any dangerous air pockets. And finally, Step 4, testing. Cube testing and slump testing to scientifically prove that concrete strength. When an expert like Abubakar is on site, he is literally breaking down every single one of these details for the workers. There's zero guesswork. Everybody knows exactly what they're doing and why.
Section 3, Biggest Construction Mistakes. But what happens when that professional supervision just isn't there? Well, now what's really interesting about this slide is the stark contrast. On the left, we're looking at a total nightmare. Weak concrete and honeycombing. This happens when the mix isn't properly compacted, leaving these terrifying voids that just destroy the structural integrity. But look on the right, you see the true engineering standard. A perfect water-cement ratio combined with proper compaction through professional vibrating. That right there is how you get rock-solid, impenetrable strength. It is literally the difference between a failing column and one that stands for generations.
And the devil is absolutely in the detailing. Just look at the massive difference between ignoring steel spacing on one hand and strictly adhering to IS code detailing on the other. If you go with low cover and the wrong spacing, moisture is going to penetrate, that steel will rust, it'll expand, and boom, you get those slow-motion cracks we talked about earlier. But by using precise cover blocks and following strict IS code detailing, the steel is perfectly encased, it is protected, the science is honored.
Section 4, Science and Construction Specifications.
So let's pull back the layers for a second and look at the invisible forces at play here. Because behind every single shovel of dirt, behind every massive concrete pour, there is a whole world of complex mathematical science silently holding everything together. Let's talk about the load path. Imagine tracing a heavy, massive weight starting all the way up at the top roof slab. That weight, it doesn't just sit there. It travels. It flows downward dynamically, almost like a river of invisible force, moving seamlessly from the slab, routing through the horizontal beams, pushing violently down through the vertical columns, straight into the massive foundation, and finally dispersing safely deep into the earth. Managing that invisible journey, that is the absolute core of an engineer's job. And to manage that intense load, we rely on a perfect marriage of materials, compression and tension. Picture concrete as a massive, impenetrable shield. It is incredibly brilliant at handling crushing, compressive forces. But it absolutely hates being stretched. That's exactly where the steel comes in. The steel rebar acts as the muscle, resisting the pulling, tearing forces of tension. When they work perfectly together in reinforced concrete, they masterfully handle the chaotic shear stress and moment forces that are actively trying to rip the building apart.
And this brilliantly illustrates exactly how we guarantee those materials actually perform on site. We aren't just guessing here. We use exact IS code specified mixes for concrete grades. We strictly utilize high-yield strength steel. Lap lengths, which is where two pieces of steel meet, those aren't estimated. They are precisely, mathematically calculated. And curing, it isn't just spraying water around, it is carefully monitored chemical hydration. Following these strict specifications removes every single ounce of guesswork from the equation.
Section 5. Perfect result and quality. So what actually happens when you combine that uncompromising science with rigorous professional site supervision? Well, you move out of the math and into the real world, and the result is nothing short of majestic. Imagine a cinematic drone shot reveal flying over a beautifully finished luxury villa or a towering commercial building. The golden hour sunlight is hitting that flawless exterior perfectly. But the true beauty? It isn't just skin deep. Whether we're talking about a school, a hospital, or an apartment building, the real masterpiece is the safety hidden within those walls. Because rigorous quality control was followed at literally every single step, the people inside get to experience the ultimate luxury, and that is absolute peace of mind.
Now, this level of stunning, documentary-quality construction isn't just some abstract concept. It is exactly what Bhavakati Construction delivers on a daily basis. They blend those top-tier materials with relentless professional supervision to ensure on-time delivery of incredibly safe, spectacular structures. So if you're ready to build your dream home and you refuse to compromise on safety or science, you can absolutely reach out to their base right in Hoonigan.
Which brings us to their final, defining motto. ಗುಣಮಟ್ಟದ ನಿರ್ಮಾಣವೇ ನಮ್ಮ ಗುರುತು. Quality construction is our hallmark. It's not just a slogan, it's a promise backed up by physics and real engineering. So I'm going to leave you with this thought today. When the time finally comes to build your own dream home, to put a roof over your family's head, are you going to leave your structural integrity up to chance, or will you demand the proven science and rigorous supervision of a true expert?
Thank you so much for joining me on this deep dive into structural engineering. If you found this breakdown as fascinating as I did and want to continue this journey, make sure to hit like, share, and subscribe for even more incredible civil engineering knowledge. Until next time, stay curious and keep building.